Okay, what's up? Okay, we are back. We will be learning vectors today. It's our first day learning something about vectors. I have learned about it, various topic about like cos theta. What does the what is the angle between vectors? Okay, we are back. We will be learning vectors today. It's our first day learning. Okay, today in this stream I will be targeting how lines and vectors are related. What is a line? What is a linear dependence? Okay, we will see what is linear dependence and see what is line. What is this? What is linear dependence? LD. What is linear dependence? Okay. Okay, if we look at in our elementary class, uh, sorry, our elementary class, we have learned algebra. Okay, algebra where we have given we usually take equations in form of x and y, solve for it. So okay, now we will be only talking about the equation of a line. Okay, equation of line. Okay, okay. Equation of line is defined by ax plus by equal to c, where a b c are constants. So this equation will form a group of points that are continuous. So this is the equation of a line. This is a line, then equation will be general equation of line will be given by x plus by plus c. If you look at this equation, there is order of y1 for the power of. If you look at the power of of the variables, we will see only it is raised to 1, and this is the what we will say, this is a line equation. This equation of line. Now how does a vector and line correlate? How a line and vector correlate? Okay, okay, if you look metrically, line is a collection of points. Okay, continuous points, right? If we take this as a line, all the points lies on this are a part of this line AB. So if we think about this line, we take this point A and B. If we walk through every next point of A and we can move to B, and similarly from B we can go to A by moving left of B, or we can move right of A to reach B. So these all points will form a line. So the this is also a definition of vectors, where vector is a vector defines the coordinate of a point, right? Vector defines the distance. What is the distance of a point from the origin? So this vector is also a line, right? So this is how we see what is vector and a line, how they are related. Okay. Hmm. Okay, let's see the parametric form of vector and a line. If we are given a vector, if we are given a line represented by 3t comma y equal to 2t, so we can write this in a form of x comma y vector. We take the common t and we write 3 comma 2. So we can see we can write x and y in the representation of a vector. If okay, for this equation 3x plus y equal to 0, if we draw all the points that satisfy this equation 3t plus 2t 0, we get all the points lying on a line. So equation has a single parametric equation. Okay, let's look in an let's solve some examples. Example, let AB be a vector, no, A be a point 2 comma 3, and let B be a B 3 comma 1. Let me change the color of it. Should I change? This is very so tacky. I think I will go for lavender. I like this. Yeah, this much better. Okay, now explain vector AB is a explain y. Okay, explain y. AB is the graph of by line AB is the graph of the parametric equation given by x and y 2 comma 3 plus t comma 5 minus t comma 5 minus 5 minus 2. Okay, so these are the points. So okay, let's take the equation of a line. Equation of a line for this is given by ax plus by. Okay, I make a lot of mistakes. Ax plus by equal to c. We will put on the value a and b here. We first put 3 comma 2 3 x sorry a we don't know what is the value of a. We put 2, we put 3, y equal to c. We get equation 1. Another equation, since this is also a point of the this equation 1, so this b will also satisfy it. So we plug in for x and y, plug in the x and y equal to c, second, and what we do is we multiply 3 by 2, this third equation by 2 and the second equation by 3, so and subtract it. So we get 6 8a equal to c, a equal to c by 8, b equal to okay, and then we solve for b. If let me check my 3 or 6. and 6. 6 and 6, that is 12, right? I did a mistake here. This is 6x plus 6x is 12x, so this will be 12x. So x is equal to c by 12, and y is, what is y? I don't know. 12. Okay, in plug in the equation 1, it is easier to solve for in the third line. So equation 3 plus 3 3 4s 3c by 12, so we get 13. 15 c by 12, so y is 15 by 12. See, y is 15 by 12 c. Okay. Okay, c is your constant. Okay, I did it wrong. I don't want to solve for a and b. Let's assume y is equal to mx plus c. Y is equal to mx plus c. C is something constant. I don't know. How do I solve it? I don't know. Oh, what the fuck, bro? How do I solve this equation? So we get x and y as a. I'm getting if you multiply by this 2 and 3 and 3 minus 1. I don't know why. How do I solve this, bro? Explain why a and b is the graph of the parametric equation. Why is this equation a parametric equation of this? If we look at x and y, we do the vector addition here. First we vector multiply, vector multiplication and vector addition separately. T and 3 minus 2t. So these are the x and y's. Plug in, if you plug in t, we get the values. Okay, so if I remember, my equation was like c by 12. X is 3 by 12, y is some around okay, a was around, right? A and b, and was 15 by 12. This will be, if we multiply by t has a c has a multiple of 12, so I get a 1. Okay, I solve it again, right? 2x plus 3y, no, a and b, we will be solving for 2a plus 3b equal to c minus 3a plus y equal to c. Oh, I did it wrong here. If we multiply by 3 here and subtract, this is 9 plus 2 is 12a, 3 and minus 2, so this is minus 2, is 2 by 12, b is 1 by 6. B is, let me solve for b. C well, this 3 by 6 2, and this will be 3 by 2c. If we multiply by 6 here, 6, still not getting the answer. Why the fuck? What the fuck? Okay, so okay, I solved it here, right? So 9 minus 2 is 7 minus 2 plus, yeah. Why am so noob? I don't know. I will be looking at the answer. I'm not getting any shit. Let me look at the hints. Okay, I still don't get it, but what is the answer saying? That is, if if A and B, if we draw on the Cartesian plane, 2 comma 3 something here around, and 3 comma, if we draw this, then if we take the difference of x and y's, so difference of delta x and delta y is around 3 minus 5, and y is 5 and minus 5 and minus 2, and that is minus 2. I think that's okay. And if we multiply it with any constant, if we take 2 comma 3 as a starting point, 2 comma 3, and we subtract some multiple of minus 5 minus 2, some multiple of this delta 1 time 2 time, we will eventually reach from A to B or B to A. So B to A. So that's why this is the geometrical meaning of the equation. So what the difference is giving, it's giving us by what should be at each step, by what should be we reduce it. If we do it infinitely many times, okay, and so we will eventually reach A. By how much should we reduce that? This t minus 5 plus 2 is equal to minus 3. Okay. Minus 5 t plus 2 equal to minus 3, and minus 2 t plus 3 equal to 1. If we solve for it, we get 5 and t is equal to 1. We do it, so we have minus 2 and 1 t1, and do t for 1. When t is 1, we'll get for t equal to 1, I think we will get point B. 2 comma 3 plus t comma, okay, t is 1 minus 5 minus 2. Okay, we are getting minus 3 and 1. Yeah, this satisfied. Okay, now I get it. What we do, we were asked why if A and B lies on the same points of a line, so we have to explain why the line AB is the graph of parametric equation of the in vectorized form. Okay, and this is the deltas, difference of the x and y's, and this is the one of the coordinates. We are going from A to B, so we will, if we plug in t1, we will reach B. If we t0, we will be at A. If some intermediate values for t, that is real values, it will always be on the line, and I have to check why is it. I know for 0 and 1 it's satisfied, but I don't know why. Okay. So, mm, okay. In vector form, we write a and b has b minus vector a. So that's why we subtracted it. Okay, I get it now. Graph. We need the what is the graph of b and w. Okay, we'll do the another part of this question. Is this only parametric form? Is we are asked to explain why is this is the only parametric equation of form x comma y equal to two vectors u plus I t y, where t is a constant v, whose graph is ab. Graph is ab. I think whose graph is ab, right? U is the starting vector and v is the vector a and b. Vector ab. Vector ab is given by this, and for t multiple of any t we get u, any point, any vector of that from the origin. Okay. Is this the okay? Yeah, I think this is the best because we have exactly two. We cannot reduce by other. We cannot make u and v as a zero until if v and u are, okay. We defines we def other this function tb defines the direction plus by how much should we reduce to move to point u, to move any point of the graph. Okay, this gives us, so okay, let's see the answer. Okay, basically we can have uh, many vectors defining the same line. We can have many vectors defining the same line, like this was the first vector that defined x and y. This equation defines the parametric form of vector parametric form, and if it reverse the direction ba, then minus ab, then ba is equal to minus of ab, then we get 5 comma 2. So to the starting for x comma y will be given by 3 minus 3 comma minus 1 plus s comma 5 comma 2. So this is also another. and we can get infinitely many vector equations. Like we can plug S as a vector non-zero multiple, right? Let S is equal to 4k. So k for 20 and 10, 20, 20 and 40. So new equation 3, 1 will also be a new vector. So this equation will also have AB as a graph. Okay. Okay, now in another question, if I ask for non-zero vectors, let u and v be a vector where v is non-zero vector, explain why. We need to explain the parametric equation x comma y plus equal to u plus tv fits our geometric description description of line. I need to explain why. Okay, so we need if we are given vectors two points, at least we need 2 points, right? So that will uniquely define u and v, u comma v will uniquely define line, and the moment of u and v will give us the directions, and direction is given by difference of vector a and b is a vector b minus a, or if we reverse the direction b comma a, from a to b I am going from a to b, vector a b represent I am at a, I am going to b, ba defines I am at a, I am going to b, so I am at b, I am going to a. Okay, I am at b, I am going to a. This what leads to the vector. This is the vector definitions. So and t give us by how much at each iteration we should move, so we reach any point of line in that equation. For t0 and t1 we get our exactly u and our given points a and b, and any other integer in between them gives us a point that lie on the equation. So this is how the parametric form give us a geometric interpretation of a line. If we look at the solution 9.16, okay, let's see. Let The solution, formal solution is like u b vector u1 plus u2, and the equation x comma y will be u plus tv, and we plug in the u1 u2 plus tv x and y. This equation consists of u1 comma u2 together with all the points, all points we can reach by starting at u1 comma u2 and move in the direction of move in the direction of v, the direction of v, or going in the direction opposite to v, or going in the direction of opposite is governed by t. Okay, so formal definition be x vector xy vector parametric equation x comma y equal to u plus tv, where t is a parameter and this equation denotes a line, and v is a direction vector of the line, and we will sometimes describe a direction of vector of a line as being parallel to the line. Okay, the direction vector of a line is not unique. We'll see in the further example how direction of line are related. Let's see another. Let v and w be v and w. Okay, now let x comma y be a parametric equation. This equation be a parametric equation where s is not not a scalar multiple, where v is not a scalar multiple of where v is not scalar multiple of w. Okay, v is not a scalar multiple of w. Okay, so s times v plus t times w will never be equal. This two will be never be equal, and we have to tell why when s is 1, x comma y to v plus tw, what is the graph of this? Okay, v will be a point in the Cartesian plane, and w will give us the direction in which we are moving. Will give us the different lines, infinitely many possible. And for b, x comma y to 2v plus tw, as tw. So we have moved twice. Okay, we moved by twice. We increase x and y's of y v by twice. So we are we are two times. Okay, where the distance is increased from v comma to v, the distance is increased by twice 2, or v increased by v. So twice, right? We have increased the distance twice. So these two equations are similar. So when we are, so these two equations are similar. This is v, then this is 2v. So whichever direction we pick, we also move in that v also. This 2v also. They're both the same equation. Okay, in the third part we have to show that x comma y v plus tw is equal to x comma y sv plus tw. So how can we do it, right? So I need to remove s from here. How will I do it? So let me write it in the let me write this in s minus v. Let v be u1 comma u2, then sv will be s time u1 s time u2 plus tw. So we only keep one u, right? So this will be s minus 1 u plus u, s minus 1 u u1 u2 plus u2. Okay, I plug in this here. So that will give me s minus 1 u1 plus u1 s minus 1 u2 plus u2 plus tw. I do the reverse engineering and the vector addition, so I will get an another vector s minus 1 u1 u2 plus tw plus u1 comma u2. So this is the equation we in the end. Okay. And okay, this is the initial vector. Initial vector. This is if we pick these initial vectors, this is the parametric, first parametric x hat. Let us assume this x hat. Then this will be x minus 1 u1 u2. So this is the scaled version of the equation, or the base equation. So this is the base. This is the scale version, right? If we take the vector a and vector b, and these are the constant, I think this will be a constant. I have to prove this is a constant, right? No, constant multiple, right? Kind of. Okay, I move.
Okay, show that if the graph of xy, vector xy, is equal to u plus tb contain p and q, the graph is the same as the graph of xy, p and q plus sv. We define a linear algebraical we define a line linearly in line algebraically using a point on the line and a direction. This part asks us to show that no matter what point of the line we choose, we will get the same line. Okay, since p and q is the graph of x comma y, since p comma q is in the graph of xy, we have pq equal to u plus t1b the same as some scalar t1. So we derive the u as p by q, pq minus tb. Substituting this into the xy u plus tb. So okay.
I'm getting exhausted. Okay, I will solve another question 9.18. Equation 2x minus 3y equal to c as a parametric. Okay, we represented it as a parametric equation form. So okay, how do we do that? We are given a 2 and 3. Well, let's derive 2 points. X0, y will be x0, y will be minus 2, y0 y0 x is 3. So we can get the direction of it by 3 minus 2 x3 from order. Choose the direction A and B. So direction of A and B is B, and 2 plus 0 comma minus 2t. With here we put the t. This is the parametric equation, and another will be x and y. We go in the opposite direction, right? 3 minus 2t plus 3 comma 0. La 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 la. The official solution is that x is equal to 3 by 3 by 2 v plus 3. Let t equal to 1, then x is equal to 3t 3 by 2 plus 3. So we do the discarding here. 3 comma 0 and t comma 3 by 2. This is also fine equation. We have one. Okay, show that the graph of by ax plus y where at least a and b from 0. Okay. we have to show that in the next part of if y is equal to mx plus c, and then y is equal to ax plus by plus c. Sorry, this is the equation. We have to find the parametric form. We divide this equation by a and bring all the terms to right hand side. C, we have minus c minus a by b x b by x. Let so sorry, we define for y. X is equal to c minus a by c minus a. This will be b by t y. Let y be t, y be any t, then x will be c divided by a minus b by a t. So let's write this in parameter form. C by a comma 0 plus c by a minus b by a 1t. This will be a parametric equation. Nice form. Or we can switch a by b also here. We can switch dividing by something, right? 0, let a be 0, then y be c by b plus t be 1 minus a by b, and y is 0, right? We change the parametric equation if a or b is 0. Okay. If you want to know the slope of a line, how you will be knowing that? How we relate the slope of line to the parametric equation xy, vector xy u plus tv. How it is related? If we see the vector v is a direction gives us the direction, right? Vector v gives the direction. If we divide the x and y, we get the direction, right? Y by x del y del x equal to direction, right? So vector v, component of vector v, x component of vector v, y component of vector v, and x component of vector x v. This gives the direction, and so this gives us a slope. Show that the graph of okay, if we see the other equation see the previous equation, c by a 0 plus t minus b by a 1. So here this is the slope, minus b by a also gives the slope if it divided by y. So x gives us the slope, x component. Okay, we have to show vector x. Another part we have to show xy equal to u plus tv and ax plus by equal to c. And this graph of this is similar to the graph of this. How we say this? So as we did in the previous derivation where u was minus c by a plus 0 plus t was minus b by a 1. So that's all. I think that's this graph also gives this is the wet line equation. The graph of this gives us the graph of the line. Okay. This is a constant dot product u1 v2. This is a dot product. Okay, and v2 be pb minus v1 and v2 be a. So this gives an equation. Oh, my head is spinning, bro. This is tough as fuck. Okay. Man, this was so tough. They have not even scratched the surface. I'm looking at a PDF and learning things. Such a good PDF, but uh, okay. Okay, well, let's see an example. The vector v a v plus bw a vector is a br scalars is a where vector a and b are scalar is a linear combination of v and w. In this problem, we explore the graph of all linear combination of pair of vectors. X, y. What is the graph of v equal to 2 1 plus and w 6 comma 3? Okay. Okay. The graph will be given by 2 1 plus direction of a to b to b 2 from b 6 minus 2 is 4, 3 minus 1 is 2 times t. We can either take the common, right, to common t. So this will also give k is equal to twice of 2, k is equal to twice of half. Okay, I need to show this in the form, right? in the linear combination of s and v. So xy will be s of 2 1 plus t of 6 3 will be 2 plus 2s plus 6t or 2s 1s plus 3t. Each component in is a double. Okay, here we can see the relation between x and y. So x is equal to twice of y. First component, the x component, is the double of the second component. So this is graph is a line. कौन कहते हैं भगवान होते नहीं, बस दिखाई तो नहीं देते हमें कभी। भाई भगवान दिख जाएगा मेरे को वेक्टर दिखते दिखते। एस एन टी तीनों कॉम्बिनेशन में दिख रहे हैं, एस प्लस एस एन टी। तो इससे क्या बन गया, दे आर लीनियरली इंडिपेंडेंट। शिट, this was no. Okay, here SNT is the entire Cartesian plane. Samavai chori S1, 0. ठीक है, s is minus 2t plus t. Let s be a plus 2t, b and t be b. So this gives a by b. So this is also entire Cartesian. Here we could see that v is a scalar multiple of w, v and w. V was a scalar multiple of I'm going to sleep, man. I can't deal with this shit anymore. Okay, this was all about it. What we learn. they have the ax plus this graphical form of this line is given by vector x by vector u plus tv, where v is the direction and use the any point. So this can be we can have infinitely many unique points with the direction similar, same direction same. So we so this vector is not unique. Parametric vector is not unique. Unique doesn't have a unique. So for if you want to see the equation, we just see the direction where it is going. Okay. Shit. And we see that we all in the end. Okay, before that we see that why does the vector parametric form the graphical view of the lines and vector, how they relate. Parametric equation nicely fit with the definition of vector and give all the points. In the linear combination, we see the vector vx plus vs, vector s is a scalar times the vector plus w be a scalar, k t be a scalar and w be a vector. So a linear dependency between them. In the first example, where the vector w was the vector v was twice vector w was vector v was half the w, half of v. Vector v was half of w. Vector w was twice of v, and so they were linear independency. They formed a line, and the vector v and w, and another there was no linear dependency. So they span all over they all the points cover the all the span, right? Okay, let's end this here only. I can't do more math here.